YouTube? It's me, Jordan, aka Cheat Buddy. Last video we left off, we're trying to find a local variable for EBP minus 14. So we're going to go ahead and set a breakpoint on EBP minus 14 here. And like I said in the last video, EBP minus 14 is getting passed to this call here. This local variable is going to get passed to this call, and this call is going to set the value of that local variable. So we did already went into the function and find, of course, we found out what was being moved into that local variable, but now we need to find the source of ECX once we go into that function. So that's what we're going to do now. So you see right off the bat here, it's moving 0 into ECX. But let's keep going through the function to see if anything else happens, because it also says here that it's moving something into ECX. So, we want to see. So it's saying that it's saying that it's moving EAX into ECX, okay? Let's find the source of EAX. We go up and we see EAX gets his value from ECX. Huh, ain't that funny? So we started off needing to find the source of EAX. Now we found the source of EAX. Now we need to find the source of ECX again. And I tell you guys, I'm real consistent with these comments, because they're just so helpful when you're tracing the code backwards. So that's that. We're gonna go ahead and go back to the tracer, and we're gonna jump back to the main function, okay? So this is where we set our breakpoint originally. Let's go ahead and remove it and run the game. Okay. So we need to find the source of ECX. This is the call that we just went into. So before that call, we see that ECX is getting the value of EDI. We're going to go ahead and add that to this code list, and we need to find the source of EDI. Press OK. Now we're going up, and now it's saying that EDI gets the value of ECX. So we need to find the source of ECX again, and we're at the very top of the function, so we could go ahead and minimize the current function, and now we evaluate the next one. Now we see here trying to find the source of ECX. Says here that ECX get its value from ECX is getting loaded the address of ECX plus C4. So whatever address is in ECX is going to add that to C4, and then it's going to put that back into ECX here. So it's going to do this first, execute this on the right side, and it's going to put that in ECX. I'm going to add that to the code list, and we're going to say find source of ECX. Okay. Going up, going up. See here that ECX gets, we see here that ECX gets, this local variable here, EBP minus 14. Remember, minus means it's a local variable. It does it again here too. We're going to keep going up and see. And, we could kind of get an idea that we're in the right place, because it's telling us all type of things about our physics, and we're seeing a lot of floating point instructions. So we're just going to keep going up. What were we looking for? We're looking for EBP minus 14. It says here that EBP minus 14 is equal to EBX. Alright. Slacking on the comments, bro. My source of EBP minus 14. Now we found the source of that. Now we need to find the source of EBX. find the source of EBX. And we're almost done. I think we got like one more, and then we could go ahead and start. Now we need to find the source of ECX. We're at the top of the function. So again, back to the tracer, minimize. All right. This is the return address. This is the function that we just got back from. We're trying to find the source of ECX. It says here, ECX is getting moved EDI plus BA0 now. Remember in the last video, I told you guys I already did the hard work. So I already know that this here is a static address. This is a static global pointer. And you know, how do I know that? It's because I did it earlier. Remember I was telling you guys about the offsets. I try to keep my pointers at least 6 offsets minimum. But the more you have, I think the more you have, the better. I guess it really depends on the game though. If it's a complex game, then I say more offsets in your pointers are better than less. So there we go. EDI is the base class, and like I said, I know this because I've already searched for it. Now, this is the return address, right? That from that function that we just came back from. Um, Now, the return address tells us that EDI hasn't changed because it's being used up here, and it's being used up here as well. So we could set a breakpoint, but you know, there could be other code that's calling this function, and it might not give us exactly what we need. That's why that break and trace is really handy, because now you could just see the you can see EDI here, and this is what it said that EDI is. Um, so few things to check. Let's go ahead and change this to 4-byte hex. All right, let's go ahead and copy this, and let's go to it. And make sure EDI 3404. Hurry up. I'm confused. Hold on, guys. So I found out what the issue was. I had to redo my trace because when I had closed the application, it was still showing the old addresses. So now we got the up-to-date addresses for EDI, which is the parent class of all those classes that we're looking at. All right, or all of those objects, I should say. It's the parent of all of those objects that we're looking at. Okay. So we're gonna go ahead. We're at EDI right now. We're gonna go ahead and have a look at to see if this is its virtual function table. And now you can see we're in a read-only section, and we see a bunch of different addresses. Let's check to see if they're functions. And as you can see, start with a push, ends with a ret. It is a function. All right, nothing new here. So let's go back. Now, real quick, let's say you didn't know anything about this class. Before we even created the pointer, I'm just gonna show you guys a little trick. So go ahead and change the display type to byte hex. You could do this for any class in any game. You could scan the virtual function table, and typically when you do that, it will give you the constructor and the deconstructor for that class. And so I did, in our little outline here, I did kind of do a lecture already. I believe in a video I did explain already. So this is how you would create a constructor in C++. You just use your class name, and then you just put, you know, some parentheses. Oh my gosh. Class name, put some, I hate this mouse, man. It's pissing me off. Let's close this. Don't need that anymore. Anyways, class name followed by parentheses, right? And then we're using the this keyword to change, is to say that whenever this class is created, because you see we use the entity keyword here to create this. So once Prince of Oblivion is going to get created, it's going to call this constructor function, and it's going to set these default values for it. Now, over down here with the little squiggly line, it's basically the same, but this is the deconstructor. And so what a deconstructor does, that's basically called when your object is destroyed. So let's say that my player, let's say I die, let's say I fell off the map or something and I completely died and I had to be respawned. So this deconstructor could possibly be called, and it'll clean up memory, and then it will, call a function to respawn my player or something. So if you wanted to find those functions, they could have some useful information for you. And so we're going to go ahead and do that right now. So to do that, you want to set your value type to array of bytes. You want to go ahead and uncheck writable. You want to have this set to hex, and you're going to and go ahead and copy the first 4 bytes at the beginning of that class. So you see I'm at that EDI. And you're going to copy these first 4 bytes. Can't talk. And then hit first scan. Give it a second run. All right. So we've got 2 results. You want to right click the first one and click on disassemble. At first it might look a little weird because you're trying to disassemble it from a you're not at the beginning of the function, so Cheat Engine still have to figure out what's going on. But as you can see, when we disassemble this function here that we scanned from the virtual function table, uh, when we scan for the virtual function table pointer, basically, it takes us to this function here. And this function, what you see, is basically the constructor function for game. As you know, game is data model. So you could imagine this is like the parent, game is the parent over everything. So we're using this game uh, parent class to reference our entity. And as you can see, game is another word for data model. It says here, the data model, commonly known as game, is the root of all Roblox parent-child hierarchy. Its direct children are the services, which are workspace and lighten, and then a game that acts as containers for everything else. Okay, so yeah, as you can see, the data model is the very root, at the top of that hierarchy in the game. So all the objects and stuff is in there because it inherits everything from all the other classes. So we know that this is a game, and this is the constructor. You could kind of see it initializing all of the different locations in memory using these different offsets and stuff. It's just kind of pre-initializing values, setting stuff to 0, kind of like how I was in our little demonstration in our constructor function. It's just setting up values. The similar situation here, and we could keep going down, see if we find any more useful strings or anything like that. I don't really see anything too useful. I'm just kind of going through just to see if we can analyze the function a bit more. Okay, nothing there, but here you can see, and here's the deconstructor for it. And you won't really find too much on here either. If you were to step through this code for the deconstructor, you'll probably find it calling some kind of a deallocation function, like it might call like free, but uh, based on whatever library they're using, there's a function called free that you could use to free up memory. And within here, it's probably calling that. And you could see it could kind of have some minor strings that say RBX mutex destroy. And, this kind of gives you a hint that it's getting rid of everything. So there you go. That's how you find constructors. Um, and I'll be putting some videos in the description uh, if you guys want to learn more about those. Let's see, create a monthly fund. Yeah, this is what we're about to do right now. We're about to create a multi-level pointer. using this base game class. So to do that, what you want to do, that EDI, you want to go ahead and copy its address. So you can just right click, go to address, click on copy. All right. Well, I'm not sure if it lets you copy it from here. Yeah, when I right click, it doesn't do anything, so I guess not. Now that you've done that, you want to switch over to 4-byte hex, and you want to go ahead and paste that, like so. And let's change this back to writable. So what we're doing essentially here, we're just scanning for the parent class, which this is game. So we're just gonna scan for it. And now, whenever in G-Engine and when you see green addresses that look like this means that it's a static address. That means that every time you point to this green address, it's always going to be pointing to, now you do have to find the right static address because it looks like some of these are changing, but the first three seems to be good. We're just going to hit next scan a few times and see if we could knock those results down. Okay, so we're only worried about the green addresses, and we have about 4 of those. Oops, I added one more than once. 1, 2, 3, 4. Okay, so we have all of these, and we have all of these static pointers, and they point to the game class. Okay, so what we're gonna do now, we're gonna go ahead and using these static pointers that we found, these globals, we're gonna go ahead, or static addresses, I should say, we're gonna go ahead and use them, and we're gonna link back to the player's float. So this is how you would create a multi-level pointer without the use of the pointer scanner. So first thing, I'm just going to take this address here and copy it. I'm going to do you're going to add address manually and check pointer. And in the bottom field here, you want to put that address that you just copied, this one here. And now you want to do your offsets, okay? So remember I told you offset is everything that's after the plus. So the first offset we see here is BA0, okay? Let's go up some. Remember, we don't worry about local variables, so skip, skip. We see the second one, C4. All right. This is why I kept adding all of this stuff to the code list so that we could reference it, okay? So we're still going up. Seeing the EBP 14, C plus 14 at offset 14. All right. We go up. We see 4B8 at offset 4B8. Oops, 4B8, okay. I'm gonna click on OK, and then I'm gonna go up some more so I could see the rest. Okay. All right. The next one is 4. See that ECX plus 4 there. All right. And then followed by that is 2D8. Then followed by that is A8. And after A8, we got 5C. And then last but not least, we got D4. Go ahead and change this to float and press OK. So what you want to do, go ahead and change your, once you created that pointer, go ahead and click browse this memory region and change your display type to float. Now, don't remember if you guys remember this, but this very function here, we're talking about move ups in one of the previous videos, or move UPS, and basically remember this could move up to 128 bits, or in other words 16 bytes. Okay, so this 100, well, I could change the format. Mm, just do this to make it easier to understand. Okay, so this is the first. This is the first 4 bytes that it's retrieving. Okay, then it's retrieving the next few bytes. This is 8 now total, and now the next few. This is 12, and then of course uh, going up here all the way down to here, you get 16 bytes total. So if you count this, it's going to add up to 16, everything that's highlighted. And so because of that, we need to make some adjustments because it's not pointing exactly to our Y. And like I said, from experience, just experiment with the values. I know that the Y is this 3 here. So it says that our pointer is at D350, okay? And then at 5,4, it's 0. And then at 5,8, it says 3. So how do we get our Y-axis? It's real simple. Real simple. So this pointer is pointing to 50. You see plus D4 is 350. So what we're going to do, we're going to go ahead and if we do 8, now it's going to point to that 0 that we're looking at, okay? It's pointing at 0. And now, remember what I was telling you guys in hexa to add, now we're going to add the 4 to an 8. But remember I told you guys in hexadecimal, instead of using a, 8 plus 4 is 12. But instead of using 12, in hexadecimal, you use C, okay? So you could, and if you wanted to know that, you could honestly just open the Windows calculator and calculate it. Or, if you just learn some basic hexadecimal mathematics, then, that's pretty simple to figure out. So now we got a value here, and it's always pointing to our, it's pointing to our y-axis. Let's test to make sure. Let's test to make sure. All right? Let's set this to like 600. And you see, now I jump in the air. All right. And so we're going to do the same thing. So we already made a pointer for this result here. So we don't need it anymore. Um, but what I'm going to do before I delete it, I'm just going to go ahead and each of these uh, static addresses, we're going to go ahead and replace them with this base address in the bottom field here. So all I'm doing is just copying their addresses, and I'm just replacing them with the original one that we got, so that we could have those static addresses pointing to our float as well, because it's 4 of them, but only 1 or 2 of them could be the right one. So if we're lucky. But yeah, that's essentially what we're doing. I did not mean to put that there. Let's put it here. Okay, so now the base for each of these should be different. That one says 5ED0 at the end. This says 3CC. This says B64. And this one says C44. So they're all different. We could go ahead and get rid of these results here. And so an advantage of multi-level pointers is that whenever something happens to your character, or if you close the game, let me show you guys an example. I'm gonna go ahead and get the actual value of our y without I'm gonna get the actual value for y without without the pointers. And so if you can see here, if I set this to 600, and jump 600 feet in the air, or studs, whatever you want to call it, okay? But if something happens to me, if my character, let's say I reset my character, for example, now my character is dead, and all these values are all over the place. Now with the pointers, as you can see, the pointers point to the new value. But you see the original that I had, it completely changes to something else. So if I change that to 600, I'm not gonna do anything because it's not our Y anymore because it's changed. But with using the pointers, uh, we could always have the pointers pointing to our values. So now that we've covered that, in the next video, we're going to be talking about how we could use that information to find other players, and we'll be also creating a basic little exploit later on. And let me see. I feel like there's something that I'm forgetting. Um, yeah, so the next thing that we're going to do, we're going to use this information of course, we already did create the scanner, and this is what we're going to be doing in the next video. We're going to figure out how to find moving parts and other things in the game. We're going to find a function that's required for that, and then uh, we're going to use the information from our manual multi-level pointer to find other players in the game. So that's what we're going to be covering in the next video. Thanks for watching, guys. Make sure to subscribe and like the video. And I appreciate everyone that's been subscribing. I gained like, I think 165 subscribers in the past week or so. So that's pretty decent and it's steadily growing. So I appreciate it, man. Appreciate all the support.